we consider normal distribution. Before that, let me ask you a question. What is normal? The answer is, a physician says there are normal intervals for a person's blood pressure, cholesterol, and specifies the normal range of blood pressure is 110 to 140. So, by measuring these variables, a physician can determine if a patient's vital statistics are within the normal interval or if some type of treatment is needed to correct a condition and avoid further illness. The question then is, how does one determine the so-called normal intervals? Next, we consider another example in which if a researcher selects a random sample of 100 adults, measures their heights, and constructs a histogram, the researcher gets a graph similar to this. Next, if the researcher increases the sample size and decreases the width of these classes, the histograms will look like this and this. Finally, if it were possible to measure exactly the heights of all adults and plots them, the histogram would approach what is called a normal distribution, which is shown in the figure. This distribution is also known as a bell curve or a Gaussian distribution, named after German mathematician Carl Friedrich Gauss, who derived its equation. Now let us see this normal distribution. A normal distribution is a continuous probability distribution for a random variable x. A continuous random variable x follows a normal distribution if its probability density function is defined as following. We observe that x and mu takes all values in the real line, sigma greater than 0, where sigma is the mean and mu square is the variance. We say x is similar to n of two parameters mu and sigma square. This is a notation we follow. The graph of a normal distribution is called the normal curve. Some more examples for normal distributions are marks scored by students, lifespan of a product. A normal distribution has the following properties. First, the mean, median, and mode are equal. Second, the normal curve is bell-shaped and is symmetric about the mean. 3. The total area under the normal curve is equal to 1. The normal curve approaches but never touches the x-axis as it tends to farther and farther away from the mean. Between this value and this value, the graph curves downwards. The graph curves upwards to the left of this and to the right of this value. The points at which the curve changes from curving upward and curving downwards are called inflection points. The most important property is that the area under the part of a normal curve that lies within one standard deviation of the mean is approximately 68%. Within two standard deviation is about 95%, and three standard deviation is 99.7%. We see these things by considering the normal curve, which is this. So here we observe that the mean, mode, and median for this curve will be one and the same, that is equal to mu. And if you find the area under this curve by integrating from minus infinity to plus infinity, we get the result as 1, that is the total area. This is symmetric about the mean, and these are the two inflection points that we discussed earlier. Here we have different normal curves with mean same and different standard deviations. Therefore, we get different values. This suggests that there are infinitely many normal distributions, each with its own mean and standard deviation. The normal distribution with a mean 0 and a standard deviation of 1 is called the standard normal distribution. All normally distributed variables can be transformed into the standard normally distributed variable by using the following transformation. So that is in terms of x, mu, and sigma. Then the formula for standard normal distribution is this. This is the graph where here we have the value sub z. We see that the mean is equal to 0 with standard deviation equal to 1. Now, we are interested in finding out the area under the curve given by this for particular values of z that can be followed by the following. First, we need to sketch the graph of the curve. And if you are interested in finding out the area to the left of z, that is left of z, we find the corresponding value of z. So the value of z equal to 1.3 in the normal table, which will be available to us. That is, in this case, 0.8907. Similarly, if we wish to find out the area to the right of the value z, we consider this, and the calculations are given in this. I strongly suggest all the students to follow these cases and thorough with these so that all the problems can be easily solved. As these slides are self-explanatory, I will be moving for the next concepts. A normal distribution curve can be used as a probability distribution curve for a normally distributed variables. Here we have an example. All of you go through the example carefully. We are going to consider this example. So here it is given that a shopper spends an average of 45 minutes with a standard deviation of 12 minutes. That means mu value is 45, sigma is 12. Now we need to find out the total amount of time a person spends in the store, or in this problem we need to find out the amount of time that is spent between 24 and 54 minutes by a shopper. So your x is this and the another endpoint is 54. Therefore we need to find out this. So we consider these in terms of z as follows. So this is x value, mean, standard deviation, and for x value equal to 54, this is the value of z2. So therefore, the probability of a shopper staying in the store between 24 and 54 minutes is given by probability of x lying between 24 and 54, that is considered in terms of z. Here the value which is greater has to be considered, then from that the value which is lesser is subtracted. This has to be followed very carefully, and after finding the value of z in the normal table, we get this. What this suggests is that if 200 shoppers enters the store, you would expect 147 shoppers to be in the store between 24 and 54 minutes. The second part of the problem is that what is the probability that a shopper stays when x is greater than 39 minutes? So probability of x greater than 39 minutes is transformed in terms of z by the following. So the probability that a shopper will be in the store more than 39 minutes is probability of x greater than 39 is same as probability of z greater than minus 0.5. This can be easily evaluated by considering the other y, that is total probability minus probability of z less than this, which is turns out to be this. So what we can conclude is that if 200 shoppers enters the store, then you would expect about 138 shoppers to be in the store more than 39 minutes. So we consider more problems in the notes provided to you. I have considered the standard engineering textbooks available online to prepare this particular presentation, and ask all of you to go through the notes which is available to you for more problems on normal distribution. Thank you.